I welcome you all in this presentation related with the subject Materials Processing Fundamentals and Practical. And today we will be starting the new topic that is based on the powder metallurgy. This is one of the primary material shaping approach where a general shape close to the desired one is achieved. In this particular presentation, we will be talking about the different aspects related with the powder metallurgy, like what are the different things that fall in powder metallurgy, starting from the importance of the powders, the powder manufacturing methods, what is the general steps of manufacturing the component using the powder metallurgy, what are the typical applications, advantages and limitations. So, as far as the content is concerned, initially we will try to talk about what it is and what are the different things fall in its scope. Then common powder manufacturing methods, like there are three common manufacturing methods which are used to produce the powders, like atomization, reduction and electrolysis, and the ball milling is also used for making the powders of the hardened brittle materials. Then what are the important characteristics? There are multiple characteristics which are of the great importance in the powder metallurgy in development of the good products. Okay, the general steps which are used in the powder metallurgy, like the blending and mixing of the powders, compaction, sintering, followed by the secondary treatment or secondary processing based on the requirement of the characteristics, say surface finish, the dimensional accuracy, or the kind of the leak tightness, or development of the coatings on the surfaces of the product made by the powder metallurgy. And what are the typical applications where the powder metallurgy is used? This is particularly used for making the components of the composite materials, like or the materials which are refractory in nature, okay, or the material or the components made of the combination of the metal and non-metallic material. So, like say we want to add build up something or develop something, carbon and graphite. Okay, so the completely different kind of the materials are brought in together. Another typical use of the powder metallurgy is to make the porous products. Okay, so like especially the bearings, porous bearings are made using the powder metallurgy. Okay, so then what are the common advantages associated with the powder metallurgy approach of the manufacturing, and the associated the limitations, okay, are related to the powder metallurgy. So about these will be talking. Let us talk about the like what it is and how it works in. So since the powder metallurgy is a manufacturing approach which is based on the use of powders. So, powder metallurgy uses the powders as a raw material. Okay, so this is the input material. Input material here is in the form of the powders. So, we have to bulk material will be converted into the powders first using the suitable approaches. So, the powders can be of the variety of characteristics. These can be like simple needle shape, these can be highly porous, these can be very rough, these can be smooth, these can be large, these can be small. So, there are multiple characteristics associated with the powders. Say size, shape is one, size range is another, apparent density and the bulk density or apparent density related with the powders, the surface impurities, surface roughness. So, there are multiple aspects related to the powders which affect the ease of flowing. You see, powders must flow and fill in the cavity of the product, cavity which is corresponding to the shape of product to be made. Okay. So, the flowability of the powders is important for making the products of complex shape especially. Okay. So, these powders can be made using variety of approaches. Accordingly, we get the unique characteristics associated with the powders made by a particular manufacturing approach with regard to the size, shape, surface roughness, okay, or impurities at the surface, apparent density. So, these are the various characteristics which affect the flowability and the soundness of the products that will be made using the powder metallurgy. So, what we do, whatever the powder, whatever the constituents are there, they will be taken in powder form, okay, and then they will be a particular proportion. You see, whatever the constituents in whatever proportion we want to use, So, accordingly the material taken in powder form, then they are identified in desired proportions, okay, say 20%, 30%, 50%, like this, different powders in different amounts. Apart from this kind of proportioning, what is also important, the size proportioning. The coarse particles of say 60%, the medium size particles 30%, and fine size particles 10%. So, proportioning not just of the constituents, but the size proportioning is also done in such a way that the apparent density is increased, the porosity of the product produced using the powder metallurgy approach is less, and very sound products are made which are free from the defects. Okay. So, that is about the powders. Whatever the powders to be used as a constituent, their proportions are identified in terms of the constituents as well as in terms of the size, and then these are mixed. So, mixing and blending of the powders is the another step. Obviously, uniform mixing of the powder is important for the homogeneity of composition as well as properties. So, what we do, we using the suitable blenders and mixers, the different powders in the desired proportions are mixed. Okay. Then this mixed powder is put into the mold cavity, okay, suitable mold as per the shape of product. So, this the mold which is a die, basically metallic die, which is able to withstand at high temperature. So, the powder particles, this mixed powder will be put into the die. Okay. So, the die will be filled in. So, depending upon the flowability, it will be filling in. If the flowability is very high, then it will be filling in very less time, otherwise it will take long. Another aspect is like powders with a low flowability may not be able to fill the thin and complex geometrical cavities. Okay. So, that can be a problem, especially the powders with the low flowability. Once the powders have been filled in the mold cavity, we do the compaction. Okay, compaction. So, in compaction, this is a powder in the mold cavity, all right. So, using the piston cylinder kind of the assembly, the powder is compacted into the mold cavity. So, there is a die, and then there will be a punch, and using this it will be compacted. So, means it will be pressurized. So, the pressure can be used from 600 to 1600 MPa, depending upon the kind of material, okay, being used, size range of the powder particles, size range. If finer the size range, it will require lesser pressure, and if the material is hard and higher yield strength, it will require greater pressure. Size also, if the powder is of the finer size, it will require greater pressure. Okay, because it is more difficult to deform the fine powder particles as compared to the coarse ones. It is easier to deform this one as compared to this one. So, we need much higher pressures than the flow stress and yield stress associated with the material, because the finer the size, greater will be the stresses it will take to get deformed. And that is important for, because powder need to bond with each other first in the solid state at low temperature. That is realized through the plastic deformation of the powder particles. So, like say these are the multiple powders, when these are pressurized, they will be getting deformed and getting mechanically interlocked like this, and will be producing the general shape. So, here because of this mechanical interlocking which is happening under the cold conditions, we can say cold bonding is taking place. This helps in realizing the product which is close to the shape desired, but it is of low strength, because the bonding happens between the powder particles under cold conditions due to the mechanical interlocking primarily. So, the strength is very less. So, in order to impart the desired strength, what we do the next step. After compaction, we attain the shape of the product which is desired, but the product has very low strength. So, to impart the desired strength, the next step is sintering. Sintering is a high temperature process where the product obtained through after the compaction is subjected to the high temperature exposure. So, like say the product will be after the compaction, the product will be taken out, partially processed component is taken out, then it is subjected to the heating. So, here temperature will be increased gradually. So, preheating will be happening. During this stage, moisture impurities, if they are there on the powder surfaces, they will be eliminated. Then at a higher temperature, as soon as goes in the sintering zone, you see here the major diffusion across the powder particle interfaces will be taking place. Even in some of the cases, the localized selective melting of some of the constituents can take place for ensuring the metal to metal connection and development of the metallurgical bond between the powder particles. Okay. Thereafter, cooling will be happening. So, sintering is one of the key step which helps in development of the metallurgical bond. Okay. Once this metallurgical bond between the powder particle is developed, then we get the desired strength. At the same time, porosity due to the volumetric diffusion is also minimized. Okay. Still, if the porosity is left, then that is filled in, or that is eliminated by the secondary processing steps like impregnation. In impregnation, what we do, like say this step, there is a porosity. So, what we do? So, the reagents are filled, or even the molten metal can be filled in to fill all these the porous zones and eliminate these pores. Sometimes the porosity is intentionally induced to make the porous components. Okay. Now, we will be talking the various things in detail related with the this approach. So, as far as the general idea is concerned, we take the powders will be made using suitable method, then these will be mixed, then these will be compacted, and then these will be sintered. And as per the need for sizing, shaping, property enhancement, secondary processing is carried out as per the need. This is the general approach of making the product using the powder metallurgy approach. Okay. So, now we will be going in detail about this, about all these various aspects. Approach of the powder metallurgy, making the product by powder metallurgy, what it uses the constituents in powder form, that is first thing. And usually it is made of the powder metallurgy is used to make the small size products, okay, like tool bits, okay, of the composite materials or refractory materials which are difficult to process by the conventional approaches. Okay. And since it uses the raw material in powder form, and it uses the specialized tools like mixers, compaction tool, and sintering in at high temperature in vacuum environment. So, the cost is generally high. That is why the powder metallurgy is used for powder metallurgy products are powder metallurgy is primarily used for making the product for high end applications, where other conventional approaches of casting, welding, machining, these do not work for making the product. And since the process is slow, first we have to make the bulk material into the powder form, and then powders will be processed by the mixing, compaction, and sintering. So, sintering is also like it involves diffusion, so that takes little longer time. So, this process is considered little time consuming, also costly due to the need of a special equipment, use of powders, use of vacuum at a higher temperature also as per the kind of material. So, the products made using this approach is little costly, and the manufacturing of the powder. So, this is one is aspect, and the manufacturing of the powder is also a very much part of the powder metallurgy. So, as far as the uniqueness is concerned related to the powder metallurgy, and which makes it different from the other conventional processes, is like it uses the material in powder form, then these are mixed using the mixers, blenders for uniform mixing of the constituent powders. This is one. Second, it uses a high capacity press for compaction, which usually limits the maximum size of the component to be made, because the pressure requirement is very high, as high as like say 1500 to 1600 MPa. So, even if to make the very larger size components, we need much higher capacity of the presses. So, availability of high capacity press may limit the maximum size of the component that can be made. And for the environment sensitive materials like titanium and other materials, we need environmentally controlled sintering furnaces. So, these are unique features. These require heavy investment for having the setup for making the product using the powder metallurgy route. Okay. Material powders are costlier than the bulk materials, that is what another. So, these two aspects make the powder metallurgy approach a little costly approach, and the resulting components are also costly. Okay. As I said, the high capacity press requirement actually limits the maximum size of the component that can be produced. by the powder metallurgy, and that is why maximum size of the product by this approach is limited by the capacity of press, size of the vacuum, because it for sintering mostly it requires the vacuum in case of the certain metal combinations for meeting the high quality requirement. Why? Because what happens if the material is in say powder form, okay, if there are a lot of gaps at a high temperature, this will tend to form the oxides, and if there is oxide formation is taking place, then it will be reducing the metal to metal contact across the powder particles, and since we want the diffusion across the powder particles, so the diffusion will be difficult if the some kind of the impurities like oxides have been formed. So what we do to avoid such kind of thing, or to eliminate the oxides if these have been formed, either the sintering can be performed in the reducing environment or in the vacuum environment. Okay. So, these things actually make the powder metallurgy approach little costly. So, the general steps of powder metallurgy involves like preparation of the powders, that is first, then mixing and blending of the powders, okay, using mixer and blenders are used. Then we have to make as per the size and the shape of the product to be made by the powder metallurgy. Just like in casting, here also we have to make the die. This is certainly of the metallic, and it is conforming to the shape of the product to be made. In this die, what we will be doing, we will be putting or filling in the powder particles, which will be compacted. So, filling the mold cavity with the powder particle mixture, and then it will be compacted. So, after compaction we get the semi processed component, that is called compact or green compact or briquette. Okay. So, this is of the low strength, because the bonding between the powder particle happen primarily due to the plastic deformation and mechanical interlocking. So, in order to impart the desired strength of this green compact or briquette, the metallic bonding is realized through the sintering, and thereafter as per the requirement of the size and the accuracy, surface finish, a special property requirement, secondary treatments can be done. Okay. So, there is a infiltration, impregnation, and the sizing and the coatings and heat treatment, multiple secondary processing can be done to achieve the specific set of the properties in the product made by the powder metallurgy. Powders play a significant role in powder metallurgy. So, the multiple characteristics of the powders like size, shape, size range, okay, this is one, and then the roughness of the powder particles, impurities associated with the powder particles, and the apparent density associated with the powder particles, these affect the compaction, these affect the filling, these affect the sintering, and which in turn affect the soundness of the product being made. Okay. So, it is very important that we learn and know about the various characteristics associated with the powders. So, characteristics of the powders, namely size range, distribution, means what is the proportion of the powders corresponding to the different sizes. Okay. The shape, like aspect ratio or circularity, surface roughness, these factors affect the flow, or you can say the flowability. So, the time required to fill, these also affect the apparent density, these affect the filling time of the die cavity with the powder particles. Okay. So, it is important that these characteristics are, the powders are selected using the powder selected with the desired characteristics. Okay. So, that the flowability of the powders as per the shape and geometry of the product to be made can be realized, because the powder flowability must be good, especially for making the complex shape products as compared to that of the simple shape. Time for filling and sintering, so the filling time will be long if the flowability is limited, and similarly if the flowability is limited, then there will be lot of voids and gaps in between the powder particles. So, that will affect the compaction, and later on that will affect the sintering because of the presence of lot of pores. Okay. The flowability also affects the apparent density, and that in turn affects the compaction stroke that is needed, apart from the porosity formation tendency. The microstructure is also affected, and then which in turn affects the mechanical properties. So, microstructure basically will try to see what is the percentage of the porosity. Okay. So, in a given volume, if the porosity is 5%, 1% or 10%, accordingly it will be affecting the mechanical properties. Okay. So, if the porosity is more, then the mechanical properties will be compromised very badly. So, the powder particle characteristics affect the flowability, time to fill, the density, microstructure, and so the mechanical properties. And these characteristics to a great extent depend on the method of manufacturing of the powder particles. Okay. So, there are three methods of making the powders. One is the atomization, second is the reducing, and third is the electrolysis. And the fourth method is also commonly used, that is called ball milling. Okay. This is particularly favorable for making the powders of hard and brittle materials. Okay. So, powder manufacturing, three common methods: atomization, reduction and electrolysis. And the method of manufacturing selection depends on the kind of economics, that is one, certainly the kind of purity that we want, and kind of the surface characteristics of the powders that is needed for as per the requirement of the product to be made for by the powder metallurgy route. So, cost, purity, and the surface features, like the few are spherical, then many are irregular, that is one, then few are easy control of the size. Okay. It can be in few methods, it can be easily controlled as compared to the other methods. In a few methods it is very smooth, and in other methods it is very rough. So, based on the requirement of the powder particle characteristics, we choose the suitable powder manufacturing method. Okay. In atomization, what we do, like say there is a molten metal bath. Okay. From this, what we do, we supply the molten metal, and it is pressurized somewhere on the route, it is pressurized. This pressurized molten metal is passed to the nozzle. Okay, of particular size. So, orifice of particular size, like say this is the one which will be governing the atomization. So, the pressurized liquid is forced to pass through this nozzle, there it will be atomized. Okay. And then it will be allowed to fall in the water. So, when the atomized molten metal droplets fall in the water, there they get immediately solidified. Okay, this is the approach. This approach is good for the low melting point metals, like say the aluminum, magnesium and zinc. So, the molten metal in form of molten metal is pressurized, and then it is passed through the nozzle. Nozzles orifice size is controlled. So, the pressure, the size of the nozzle, okay, and the temperature of the molten metal, these three did significantly control the size of the powder particles that will be obtained. Okay. So, the how effectively atomization is happening, that will determine the size of the powder particles, and that in turn also will determine the pressure, the temperature of the molten metal, and the size of the orifice of the nozzle. Okay. So, this is the approach of making the powder particles using the atomization approach. So, this approach is good for the low melting point materials such as zinc, magnesium and aluminum. Liquid metal is passed through the orifice under pressure to cause the atomization of the liquid into the fine droplets. These droplets are allowed to fall in the water bath, where they get solidified immediately, and the size of the drops being formed can be regulated by changing the temperature of the liquid metal, diameter of the orifice and the pressure being used for the atomization. Okay. And the powders produced by this method have very smooth surface and spherical. So, this is very good important information. Powders are spherical and surface is smooth. Okay. So, the Ra is low, this is one of the favorable things. So, if we have the spherical shape particles. These can be of variety of sizes as per the pressure, temperature of the molten metal and the orifice size. Okay, so that will be used for regulating the size of the drops that is being made. Important part, low roughness and smooth surface and spherical shape. Okay, then the reduction method, this method is particularly used for the high temperature metals. Okay, like it can be copper, it can be iron or it can be tungsten. So the metal in powder form means oxides of these metals are reduced. Okay, suitable reducing gases. Okay, so when we use high purity reducing gases to reduce these oxides of the metals, the cost goes high. So these metallic the powders, the oxide in powder form is reduced using reducing gases to make the powders of these metals. That is one. And then these can be crushed, graded to attain the particular size, but the size of the powders, size and shape of the powder is very irregular, which is obtained by this method. So irregular, rough, Ra is high, okay, roughness is high and the shape is irregular, and and due to both the and surface is rough irregular shape. So both these affect the adversely affect the flowability of the powder particles. So here let us talk about the other aspects, like used for making the powders of the high melting point materials such as iron, tungsten, copper. The metal oxides in powder form is reduced by the hydrogen or carbon monoxide at a higher temperature. So if the initially metal oxide is coarse, after reducing we get the, say here, oxide, and on after reducing we get the coarse powder. If we have oxide, if it is small, then we find the smaller size of the powders that is being produced. So initial oxide powder particle size governs the metallic powder that is produced. Pure reducing gas increases the cost of production by this approach. Powder particle size depends on on that of the oxides that are being used for making the powders by this method, and size of the oxides particles can easily be regulated by crushing followed by the grading, and these powders have very rough surface and irregular shape. So as far as the powder metallurgy is concerned, here rough surface adversely affects the flowability and that leads to the lower flowability. Okay, a rough surface decreases the flowability, which in turn adversely affects the compaction as well as the sintering, and the compacted part having the higher porosity, sintered products will be having the higher porosity. So that in turn will be reducing the mechanical performance. Also, if our the apparent density is low because of the greater porosity, then it will be increasing the compaction stroke length. Okay, so these are the various aspects related to the powder metallurgy which are affected by the surface roughness and irregular shape. Electrolysis is another method of making the powders. This method is particularly used for the high purity, okay, for making the high purity metallic powders. So what we do, we use the electrolysis. So say this is the material of which the powder is to be made, and the another material, another one. So another material which can be made of the, like say the metal whose powder is to be produced is made anode, and the another material which can be there as a copper or aluminum plate which is made cathode. So this is the material of which powder is to be made. Okay, so this will be made as anode, and the another material which is of either aluminum or copper, this will be made as a cathode. Okay, so let us say here now these anode and cathode will be connected to the suitable DC power supply. So the anode is connected to the material of which the material whose powder is to be made is connected to the positive terminal. So it will be made anode, and the aluminum or copper sheet will be connected to the negative terminal. So that will be made cathode. Okay, and then electric circuit is completed with the help of electrolyte, which is usually water. Okay, so once the electric circuit is completed, the electrolysis will start. So when the electrolysis starts, the material from the anode is dissolved and it starts getting deposited over the surface of the cathode. Okay. So, once this deposition continues, then the material is deposited like this in pure form. Then the material from the cathode is scratched, okay, and removed. Then this is crushed, grounded and graded. So, basically this is the approach. Material will be first deposited onto the cathode by the electrolysis approach. Therefrom, it will be scratched, removed, crushed, grounded and then graded to make the powders of the desired size. So, this method of electrolysis is particularly used for making the high purity powders of the metals, and metal whose powder is to be made is connected to the positive terminal for making it as a anode, and the another copper or aluminum plate is used as a cathode to complete the circuit in the for the electrolysis. Circuit is completed by using the suitable electrolyte like water, and gradually metal is dissolved from the anode by the process of electrolysis, which so the material is deposited on the cathode in form of layers, and these layers are scratched, crushed, milled, grounded to the desired size, and then these are graded. The shape of the powders, which is dendritic, which is produced by this approach, and variation in electrolyte composition and electrical parameters enables the production of the powders of powder particles of wide size range. The ball milling is used is it's a mechanical method which is used for producing the powders of hard and the brittle material. So, what we do here, we use the steel balls, okay, like this, and all the steel balls will be filled in a container, and then these will be disturbed using some kind of the arrangement. So, the continuous movement of the steel balls, and then material whose powder is to be made will also be put in between. So, the balls will be continuously rubbing and crushing the powders, and they will be refining, mixing. So, this method is particularly used for making the composite material powder mixture. Okay. So, the steel balls are churned continuously in presence of the materials which is to be converted into the powder form. Okay. The powder metallurgy technique, as I have said, it is used for making the advantage of this. There are many things which are in favor of the powder metallurgy, despite of being slow and it is costly process. So, it is used particularly when other processes are not really workable. So, this is used for making the products of refractory materials like titanium, tungsten, tantalum, molybdenum, and also making the products of the composite materials, making the product of comporous metals, and materials making the product of metal and non-metal combinations. For example, high melting point refractive materials such as tungsten, molybdenum, titanium, tantalum, these can be processed by the powder metallurgy, which are otherwise difficult because of the high melting temperature and very high hardness. Production of component made of the very hard material in the soft matrix, soft metallic matrix for making the composites like cemented carbide tool bits are made like this. So, there titanium or tungsten carbide powder particles are embedded in soft matrix of the nickel and cobalt. So, here the matrix is nickel and cobalt, and then these will be reinforced with the titanium tantalum carbides, okay, for making the tool bits. Now, the production of components made of the metallic and non-metallic materials such as the brakes and clutches. Another example is like making the carbon brushes, which are made of the copper and graphite, and the powder metallurgy is also used for making the porous bearings with the controlled porosity. So, porous bearings, they will be having a lot of pores. So, when the temperature is low, the oil will be filled in the pores, and when the operation is performed due to the increase in temperature caused by the frictional heating, the lubricant comes out and performs its roles. So, the porous bearings are also called self lubricating bearings because the lubricant filled in pores actually provide the desired lubrication during the operation, and these porous bearings are commonly used in refrigerators, electric clocks and washing machines. Advantage of the powder metallurgy is that it is used for making the products with the controlled porosity, that is one. It is used for making the products made of metal and non-metal combinations. It is also used for making the product of the refractory materials which are otherwise very hard and brittle, difficult to melt, and it eliminates the machining requirements because usually we get the near net shape products using this. So, the degree of machining that is required for final dimensional accuracy, that is reduced. It is very clean and simple operation, no wastage of the material in this process, and very close control over the composition, structure and properties that is attained. But there are a lot of limitations also. It suits for small size components because the requirement of the vacuum chamber, that is one, at a higher temperature, and the high capacity presses. These two things actually limit the maximum size of the product that can be made by the powder metallurgy route. The dies are expensive and the dies life is also limited. So, the dies are expensive as there has to be a unique die or separate die for each product. Life of the die is limited because the die has to perform at a higher temperature. So, it experiences a higher wear rate, and it is difficult to make the very complex shape products due to the limited flowability of the powder particles, and the process is uneconomical for a small scale production. So, and the over and above, the cost of product produced by this technique is higher than those produced by the conventional techniques because it uses the metallic powders. The process is time consuming and needs special equipments. Now, I will summarize this presentation. In this presentation, basically I have talked about the general approach which is used for making the products using the powder metallurgy, and what are the things which are to be kept in mind so that the product can be made strong and as per the requirement. Thank you for your attention.